Hi, and thank you for the invitation to present. Sorry we can be together this time, but we'll make this work. Today I'll be presenting on the Neopestalotiopsis disease that's been affecting Florida strawberry fields. I would like to start by acknowledging several people in my group who have been working really hard to collect the data I'll be presenting. In particular, postdoc Dr. Juliana Baggio and research assistant Dr. Nani Wang, as well as several grad students in the program. I would like to start by saying that the pathogen is not new to strawberry. However, the taxonomy of this group has been evolving. It's really confusing. But basically what we had reported in the past as Pestalotia longicetula, it's reported on the Compendium of Strawberry Diseases. It's been reported back in 1973 by Charlie Howard in Florida causing a fruit rot. This Pestalotia longicetula, in fact, according to the new classification, should be considered Neopestalotiopsis. More recently, there are several reports around the world of problems during establishment of the plants, crown and root rot, mainly plants that are weak and stunted and not growing well. Those reports are coming from several different countries and different continents. And in many cases, the reports are calling as Pestalotiopsis clavispora or Neopestalotiopsis clavispora, which I'll get back to it later. It's still not the correct classification for this group of pathogens, according to the most recent one. What's different than what we're seeing in Florida is the aggressiveness. That's really what's new. And in general, the Pestalotiopsis is considered a weak pathogen, more likely to attack plants that are weakened for some other reasons or stress, which is usually what we see during establishment of plants and what we used to see in the past. But that's definitely not the case of what we see in Florida. We see significant amount of leaf spots, and when the conditions, the weather conditions are favorable, severe leaf spotting and blighting of the leaves. Those symptoms, those leaf spot symptoms in particular, can be easily confused with many other leaf spots. And here's just some examples. Once you get used to it, there are differences in particular with the ones I have here now: common leaf spot and leaf scorch. The lesions are usually darker on the outside. Phomopsis leaf blight. Once the lesion develops, usually you see some sort of like a V shape type of lesion. Those two that I have here are probably the closest one to the Neopestalotiopsis and the ones that are more easily confused. Leaf blotch caused by pneumonia kumari or Titia fragari. It can be very confused, particularly when the lesions are still young, as well as cercospora leaf spot, which is not as common, but we do find. We also see a high incidence of fruit rot, in particular when, again, when weather conditions are favorable. And in this case, the lesions can be easily confused with anthracnose caused by Coledoticon acutatum. Once the lesions are sporulating, and if you take to a clinic, it's pretty easy to diagnose because the spores are quite different, but the lesions in the field are actually pretty similar. So I'd like to spend some time now going over a timeline on the emergence of this disease. So the first season we had a significant problem in Florida was 2018-19 season. At that time, we basically had 5 farms that had a significant problem. And the common link among those farms is that they all had plants from the same nursery source in North Carolina. Moving forward to the following season, the 2019-20, we had a significant higher number of farms that had a problem. And at least in the first part of the season, it was also easy to see that link with nursery source, and in this case there's two nurseries that seem to have the problem, which was the same nursery in North Carolina as well as the nursery in Canada that had received plant stock from North Carolina. But what we saw last year is that in particular during the second part of the season, after we had some significant rain events, the disease quickly spread to other fields, and then at that point it was not as easy to see that link with nursery source anymore, just because it had already moved to other plant materials that were initially clean. And moving forward to where we are now, we unfortunately have an even higher number of farms that are affected now. But what is different in this case is that we mainly see that the fields that had the disease last year have it again. We don't have as many plants from North Carolina. What we see is that it unfortunately seems like the pathogen survived from the previous season to infect the fields again during this season, and now it's moving from neighbor to neighbor once again. So what have we learned so far? Well, we know now for a fact that the isolates from those that's causing those recent outbreaks are genetic distinct from other Neopestalotiopsis that we had historically in Florida, and even the isolates from other areas that had reported this disease. I know this is hard to read, and I don't mean you to read all this names. Basically, those are all different samples that we collected in the past or we received from researchers from other countries, and those are all grouped together in this blue light box on the top. And basically, all those historical isolates, the Pestalotiopsis longicetula and what's been described as Pestalotiopsis clavispora in the past, these all should be infected according to the new taxonomy be called Neopestalotiopsis rosei. However, all the new isolates that we getting from these outbreaks in Florida, they group together in an almost clonal population, and they are genetically different than the Neopestalotiopsis rosei. We don't have a name for it yet, but we just know for a fact that they are genetically distinct. So we have used that now to develop a quick molecular test that we've been using in our diagnostic clinic to differentiate when we get samples, because the fact that we find Pestalotiopsis in a sample, it doesn't necessarily mean that you have this bad and more aggressive strain. It could easily be what we have always had out there, so we don't want to cause any panic more than needed for the growers. So, and then we have also proved what we're seeing in the field, that basically those isolates, the more recent ones, they're more aggressive than what we had in the past. So basically the light bar on this graph here, the light blue bars are samples of isolates that we collect in the past. We inoculate it on the plants, and yeah, we do get some disease, but at very low levels. When we inoculate the isolates from the most recent outbreaks, which will be the dark blue bars here, we just get a lot more symptoms than what we get with Neopestalotiopsis rosei. And here at the bottom, you actually have an example of why with rosei we got one spot here. With the new species, we get just a lot more lesions on the leaves. And same thing for fruit. This is basically the same isolates and same thing. We just get a lot more symptoms with the new Neopestalotiopsis species, just basically indicating that it is more aggressive than what we had seen in the past. And I think this slide shows the reason why it's so more aggressive. Basically, here we are comparing this population under the same favorable conditions for both, how much spores each one of those species produce. And here are two trials looking at Neopestalotiopsis rosei, the historical species we always had, and then the new one. It just produces a lot more spores under the same conditions, and I believe that's one of the reasons that it makes so much more aggressive. We have also been looking at conditions for growth and sporulation, and basically it grows well in a range of temperatures all the way from 50 to 90 with optimum around 77 in this case, but it's a wide range of temperature and pretty much what we usually have in Florida during our growing season. For sporulation is slightly different. The higher the temperature we tested, more sporulation we got. So the optimum was the highest that we tested, which was 86 Fahrenheit. Which again, it's not common, but we can have temperatures definitely around 77 during our growing season in Florida. We also know that the pathogen is favored by warm temperatures as well as water. And that's pretty much what we do at the beginning of our season in Florida. We put overhead irrigation for plant establishment. So if we're getting plants that are infected at that time and we have warm temperatures at that time, that's actually when the disease or the epidemic will start to get going. It's very early in the season, and that just emphasizes the need to start with clean plants. And then, of course, rain events, the disease can get very explosive after significant rain, in particular the rains that are followed by a few days of overcast weather where you have prolonged wetness periods. So, and that's basically what happened late in December 2019. This graph is just showing conditions for disease, green being in a low risk, yellow moderate, and high risk in red here. So it basically, for a period of 14 days, starting in mid-December to late December, we had 9 days where conditions were highly conducive for diseases in general. And after those 2 weeks, the fields that started with plants that were infected were basically looking like this. Just a lot of spotting and blighting on the leaves. There's not a lot of fruit yet at that time, but the fields that had fruit also had a significant amount of fruit rot. Now moving forward to this season and what we see now. So this is a much larger period that we are looking here from the beginning of the season in November up to now. We had a rough start with the Eta storm that went through Florida in early November. We got 6 inches of rain and winds that were close to 60 miles per hour. So during that time, conditions were obviously very favorable for disease. And then about 10 days later, we had another significant rain event. So we had a rough start at the beginning. Then we got lucky and basically went through a whole month all the way to just before Christmas, where we had a couple of days with rain. But it was much cooler at that time and as well as during this whole month here, so it wasn't really too bad. And then after this event, we went again another month with really good weather conditions, cool and sunny and much drier, until the end of January, when we had another couple of days. So basically during this 2.5 months, we had the same 9 days that weather was conducive. So things were really not looking that bad this year until last week, actually, and my slide here doesn't even go all the way to last week, but we got some significant rain and the disease has once again exploded in several fields around Florida, unfortunately. But here is just an illustration of what the plants look like after about 10 days after that Eta tropical storm. Here showing two of our cultivars, Brilliance and Sensation. And the Sensation is considered a little bit more resistant than Brilliance, which, as you can see, is pretty beat up here. But you see the Sensation is also has significant amount of symptoms. So and here's just an overall with all the cultivars that we have looked at in our trial. We had a large trial this year, mainly looking at cultivars we grow in Florida, the commercial cultivars from our program, as well as several advanced selections from the breeding program. So all the number ones you see here are advanced selections from the breeding program. So we do see a range of susceptibility, with some being a little bit more tolerant, but nothing that we can really call resistant. The one I'm pointing out here is 1631-28. It's going to be our newest release. That will be called Florida Medallion. It's very close to Sensation here, so it's kind of in the middle. But definitely the Brilliance and Beauty seem to be quite a bit more susceptible than the others. Now, looking in our fungicide trial, so we have looked at several materials in the field last year, as well as several different products in vitro prior to putting this this field trial this season. So this is our data from our field trial, and basically the data from November up to now. We do inoculate the trial, so we had a significant amount of disease. The non-treated control has over 60% of the fruit with a fruit rot. And basically all the different products in blue here were considered not effective, meaning they were not significant different from the untreated control. And we have a range of different things here. Some are not labeled yet, like pyrosulfamide. Armory is a biological control. Dragonfire here is chlorine dioxide. Metal procure. Guarda is thyme oil. Seal matrix is potassium silicate. Uptake is quaternary ammonium and oxidate. So basically only the ones here in orange were considered effective. They were significant better than the non-treated control. And the ones that I have marked on the top are the ones that are actually registered for fruit growers. Some of these are not registered for fruit growers, like Omega and Bravo or chlorothalonil. So chlorothalonil is registered for nursery use only, and it's an option, so it's an option for nurseries. Omega is on the last stage, I believe, of the registration process for nursery use only as well. So among the products that were registered for our fruit growers, we basically down to Tyrum and Switch, and here we had a combination of Tyrum and Captain that also looked good, and then 3 DMI products, and those were Rhyme, Inspire, and Tilt. Keeping in mind that those 3 are the same group, same fungicide group, FREP group 3, so they should be rotated with products from different groups. So there's not really a lot of options, and I would say in particular a lot of options that are highly effective, because as you can see, even though the statistics tells us these differences are significant, we're basically cutting down to disease to not even half of what we see in the control. So we will continue the search for alternative products, but this is what we have up to now in the season. We also been looking at heat treatment, and in this case more as a way to manage plant stock that's coming contaminated from one nursery to another. I had presented at this meeting before, in fact, about using our plant sauna or aerated steam to reduce pathogen load on plant stock. So we're now testing that same protocol for Pestalotiopsis, and the protocol we've been using is 98.6 for 1 hour, followed by 111 for 4 hours in our plant sauna or aerated steam unit. And what we see for Pestalotiopsis here is looking at the data for leaf spot. We can see that we got significant reduction when we did the heat treatment. And same thing for the fruit. We got a significant reduction with the heat treatment. But we really didn't completely eliminate the pathogen as I was hoping we would. But it still could be, we know this can reduce several other diseases, this protocol, like cholecalciferol and Phytophthora and botrytis powder mildew. So if it can reduce at least some of the load of Pestalotiopsis, it can still be beneficial for nurseries. So the question we were getting a lot before the season started in Florida was whether it could oversummer in our fields after the bad year we had last season. And unfortunately, it looks like it can, and unfortunately, it looks like it did. Many of the fields that were affected last year seem to have it again. And then there's still a question where. So we've been doing a lot of sampling in alternative hosts. If you've been to Florida strawberry fields, you know they're usually surrounded by oak trees and palms, a lot of native vegetation. So we've been sampling from those native vegetation as well as weeds and soil and crop residue. And what it makes things even more complicated is that Pestalotiopsis is everywhere. So we do find Pestalotiopsis on those other crops, but it doesn't mean it's the same aggressive strawberry SAM. So basically a quick summary of what we're finding is that when we sampling something that is in the strawberry fields during the season, whether it's a strawberry plant or some weeds in the strawberry field during the season, or rhododendron that we sample in the nursery that had a problem, all those were the aggressive strain that we're seeing in Florida. When we get Pestalotiopsis from other hosts around the fields or close nearby, we get Pestalotiopsis that is usually not the so aggressive strain. So we're really, everything we're looking so far is really pointing us towards crop residue, and that's something we'll try to do a little bit more research at the end of this season, because I do believe that a lot of those fields that are infected, in particular the ones that are really bad, and at the end of the season we tend to incorporate that crop residue in the field, and I believe that's where a lot of that inoculum is hiding from one season to another. So I'd like to close with some management recommendations that we've been given to our growers, and one of them is to avoid harvesting and moving equipment through the fields when the fields are wet. And that's because we saw that last year was really clear with workers and equipment. When the fields are wet, the spores on the fruit or on those leaves, they're pretty sticky, and they just move easily with workers or with equipment from one field to another. So harvesting when the plants are dry help to minimize this movement from field to field. And of course, that's for our growers in Florida. It's easier to do early in the season when we don't have a lot of fruit than right now, when to be able to pick everything, they really have to start early. We also, of course, recommend them to rotate, and particularly among the most effective fungicides, which really there's not a lot of options as I show, basically down to switch, Tyram, and the 3 DMI products, Rime, Inspire, and Tilt. And that particularly during the periods of where conditions are favorable, but as I've shown in my data, even with that rotation, the products are only partially effective, and especially when we get heavy rains like we did about a week ago. So we've been having a lot of discussions now about strategies for crop and inoculum termination as well, potentially crop removal of all those plants, those infected plants at the end of the season, which is I'm sure easier said than done. It's going to be challenging, but I do believe to manage this disease, we'll need to remove all the inoculum before we start the next season. And then last but not least, starting with clean plants, I think is still be key. We'll have a much better chance to manage the disease if we're starting with clean plants than if we start with plants that are already infected at the beginning of the season and we put in the overhead irrigation, and that's when we're starting the epidemics. So it would be really difficult to make it to the end of the season or to make any profit to the end of the season. So protecting our nurseries and the nurseries that don't have this problem, yeah, would be really important. So with that, I would like to thank my team for all their hard work collecting all the data. It hasn't been always been easy during this pandemic. Here's all of us on many of the Zoom meetings we have had, but they really have been troopers and kept smiling during the whole thing. So I'm really thankful for them, as well as funding from the Florida Strawberry Research and Education Foundation. So with that, thank you once again for the time and invitation, and I'll be happy to take questions if there is time for it.